There was a time when the world itself rebelled, when oceans swallowed empires, mountains shattered, and the sky wept fire. That's not just a nightmare. It's the story of Atlantis, a legendary empire that vanished in a single day and night of catastrophe. What if I told you this isn't just an old tale spun by philosophers? What if it's a warning etched into the bones of our planet, hinting at cycles of destruction that have wiped out civilizations before us and might do it again? Tonight, on Mystery History for Sleep, we're diving into the mysteries of lost worlds, starting with Atlantis and the Great Flood that echoes through every corner of human memory. Buckle up, because this journey might just make you question everything you thought you knew about our history. Let's go back to the source of it all, an ancient Greek thinker named Plato, who lived around 360 years before the Common Era. Plato wasn't just philosophizing in his spare time. He was weaving stories that blended truth with lessons for humanity. In his dialogues, called Timaeus and Critias, he lays out the tale of Atlantis like he's recounting a family secret passed down through generations. According to Plato, this story came from Egyptian priests, who shared it with a Greek named Solon during his travels. Solon brought it home, and it trickled down to Plato's relatives. Now, picture this. Atlantis wasn't some tiny island paradise. It was a massive landmass, bigger than what we'd call Asia Minor and Libya put together back then. Plato describes it as sitting just beyond the Pillars of Hercules. That's what we know today as the Strait of Gibraltar, out in the Atlantic Ocean. This wasn't your average society. Atlantis was a powerhouse, a utopia turned empire with advanced technology and unmatched military might. Plato paints a vivid picture, concentric rings of water and land forming the capital city, with massive walls coated in precious metals like orichalcum, which shimmered like fire. Temples dedicated to Poseidon, the god of the sea, stood tall, adorned with gold and ivory. The Atlanteans had it all, harbors buzzing with ships from every nation, canals linking everything like veins in a body, and palaces that would make modern billionaires jealous. But here's where it gets juicy. They weren't content with their island paradise. Driven by hubris, that over-the-top pride that always spells trouble in old stories, they set out to conquer the world. They swept through parts of Europe and Africa, even reaching as far as Egypt and the edges of what we'd call Italy today. Enter the heroes of the tale, the ancient Athenians. Plato contrasts Atlantis with his ideal version of Athens, a humble, virtuous society that stood up to the bullies. In a massive battle, the Athenians pushed back the Atlantean invaders, freeing the enslaved peoples and saving the day. But victory was short-lived. Right after that epic clash, the gods decided enough was enough. In Plato's words, there were violent earthquakes and floods, and in a single day and night of misfortune, the island of Atlantis disappeared into the depths of the sea. The warriors of Athens were swallowed by the earth, and the whole mess left the ocean impassable with mud and debris for generations. Now, you might be thinking, come on, Mr. H, this sounds like a blockbuster movie script, and you're right, it does. But Plato insisted this was no fiction. He claimed it happened 9,000 years before his time, which puts us around 11,600 years ago from today. That's deep in prehistory, before the pyramids, before Stonehenge, before most of what we consider ancient. Skeptics say Plato made it up as an allegory, a moral fable about how power corrupts and societies fall when they lose their way. After all, he was big on ideal republics and warning against tyranny. But what if there's more to it? What if Atlantis is a distorted memory of a real catastrophe, blurred by time, but rooted in something that actually happened? This brings us to the Great Flood, a story that pops up in cultures all over the globe, like echoes of the same thunderclap. Take the biblical account. For starters, in the book of Genesis, God looks down on a world gone rotten with violence and sin, and decides to hit the reset button. He warns a righteous man named Noah to build an ark, a massive boat, to save his family and pairs of every animal. Then the skies open up, rains pour for 40 days and 40 nights, and fountains burst from the deep. The waters rise until even the highest mountains are covered, wiping out everything else. Noah's Ark floats for months before grounding on Mount Ararat, and from there, humanity starts over with a rainbow promise that it'll never happen again. But here's the kicker. This isn't just a Hebrew story. Jump over to ancient Mesopotamia, where the Sumerians told a similar tale in the Epic of Gilgamesh. one of the oldest written stories we have. In that epic, a king named Gilgamesh seeks immortality and meets Utnapishtim, a survivor of a great deluge sent by the gods. Utnapishtim builds a boat on divine orders, loads it with his family, craftsmen, and animals, and rides out the storm that lasts 6 days and 7 nights. When it's over, he sends out birds, a dove, a swallow, a raven to check if the land is dry. Sound familiar? It's like the Noah story's twin, but from a culture that predates the Bible by centuries. And it doesn't stop there. Head east to Hindu mythology, and you'll find Manu, the first man and lawgiver. In the ancient texts like the Matsya Purana, a fish warns Manu about an impending flood that will destroy all life. Manu builds a boat, ties it to the fish, which turns out to be an avatar of the god Vishnu, and survives the deluge that submerges the world. When the waters recede, Manu repopulates the earth. Similar floods show up in Greek myths with Deucalion and Pyrrha, who survive on a chest and throw stones over their shoulders to create new people. Native American tribes, like the Hopi and the Maya, have their own versions of world-ending floods followed by renewal. Even in Chinese legends, there's Yu the Great taming massive floods that threaten the land. Why do so many distant cultures share this motif? Coincidence? Or did a real mega-flood scar human memory way back in the day? Scientists point to the end of the last ice age, around 12,000 years ago, when melting glaciers caused sea levels to rise dramatically. Coastal settlements where most people would have lived got swallowed up. There might have been massive tsunamis from earthquakes or comet impacts, like the younger Dryas event we'll touch on later. These weren't gentle rises, they were cataclysmic, reshaping continents and forcing survivors to start anew. Now, let's talk evidence, real, tangible stuff that makes you wonder if Atlantis and these floods point to lost civilizations. Off the southern coast of Japan, near Yonaguni Island, divers stumbled upon something mind-blowing in 1986. What they found looks like a submerged city. Massive stone structures with flat surfaces, right angles, staircases, and what appear to be roads and terraces. The main feature is a stepped pyramid about 82 feet tall, with clean edges that scream human craftsmanship. There are holes that could be post sockets, a loop road circling the site, and even what some say is a carved face or animal figures. Geologists debate this fiercely. Some, like Professor Masaki Kimura from the University of the Ryukyus, argue it's man-made, dating back 10,000 years or more, right around the time of Plato's Atlantis. He points to tool marks, symmetrical designs, and artifacts like a stone tablet with inscriptions found nearby. Others say it's natural, formed by sandstone fracturing along fault lines during earthquakes. But here's the thing. Even if natural, why does it look so architectural? And why are there similar underwater ruins elsewhere, like off the coast of India in the Gulf of Cambay, where sonar revealed grid-like streets and buildings submerged 7,000 years ago? This is where the conspiracy theories kick in. And trust me, they add a layer of intrigue that keeps you up at night, or in our case, helps you drift off pondering the what-ifs. Some folks believe governments and mainstream archaeologists are hiding the truth about advanced ancient civilizations. Why? To protect the established timeline of history, which says humans were just hunter-gatherers 12,000 years ago, not building empires. Think about it. If Atlantis was real and technologically superior, it upends everything. Books like Graham Hancock's Fingerprints of the Gods argue that survivors of these cataclysms spread knowledge worldwide, kickstarting Egypt, Mesopotamia, and more. His Netflix series Ancient Apocalypse stirred up controversy by suggesting an Ice Age civilization got wiped out by comets, and elites today know about it, but keep quiet. Conspiracists point to places like Antarctica, where old maps like the Piri Reis show coastlines that match modern ones' coastlines hidden under ice for millennia. They say Atlantis might be there, buried under frozen sheets, or that crustal shifts moved continents during these cycles. Even NASA imagery gets dragged in, with claims of suppressed photos showing underwater anomalies. And don't get me started on the Bermuda Triangle. Some tie it to Atlantean tech gone wrong, causing ships and planes to vanish. But let's pull back for a second. These ideas are tantalizing, but they're theories, pieced together from fragments. What they all circle around is this notion of cycles. The Earth has a rhythm of catastrophe, building up civilizations, only to tear them down with floods, quakes, or cosmic hits. Atlantis and the Great Flood might be memories of one such cycle, a reminder that we're not as permanent as we think. Hey, if you're enjoying this dive into the unknown, I'm Mr. H from Mystery History for Sleep, your guide through the shadows of history to help you unwind and drift off. If you haven't already, hit that subscribe button and ring the bell so you never miss a whisper of these mysteries. They're perfect for those late-night listens. Now, as we wrap up this part, imagine what else these cycles hold. Could a rogue planet like Nibiru be lurking, ready to trigger the next one? Or was the younger Dryas the smoking gun for Atlantis' fall? Stick around, because we're just getting started on the heartbeat of Earth's disasters. Nibiru, a massive rogue planet barreling through the darkness of space, its reddish glow cutting through the void like a harbinger of doom. It's bigger than Earth, with an orbit so elongated it swings by our solar system only once every 3,600 years, wreaking havoc each time. Earthquakes shake continents, volcanoes erupt in fury, oceans rise in monstrous waves, and civilizations crumble under the gravitational pull. This isn't the plot of some Hollywood disaster flick, it's the heart of one of the most chilling conspiracy theories out there. Nibiru, the so-called Planet X, and its impending collision with our world. If you've ever wondered why some folks stockpile supplies or scan the skies nervously, this is the story that keeps them up at night. But is it real, or just another wild tale spun from ancient myths and modern fears? Let's peel back the layers and see what this terrifying idea is all about. The whole Nibiru saga kicks off with a guy named Zakaria Sitchin, a self-taught scholar who dove deep into ancient texts and came out with ideas that flipped history on its head. Born in 1920 in what was then the Soviet Union, Sitchin moved to Palestine as a kid and later settled in New York. He wasn't your typical academic, he worked as a journalist and editor before turning his attention to Sumerian cuneiform tablets, those wedge-shaped writings from one of the oldest civilizations we know, dating back over 5,000 years. Sitchin claimed he could translate these tablets in ways mainstream experts couldn't or wouldn't, and what he found blew his mind. In his groundbreaking book, The 12th Planet, published in 1976, Sitchin laid out his big theory. He argued that the Sumerians weren't just telling stories about gods and heroes, they were recording actual history involving extraterrestrials. According to him, our solar system isn't made up of the 8 planets we learned about in school plus Pluto, if you're old school about it. No, there's a 12th body, the Sun, the Moon, and 10 planets, with Earth being one and Nibiru being the extra one. Sitchin said Nibiru is a massive planet with a highly elliptical orbit that takes it way out beyond Pluto for most of its 3,600-year cycle, then swings it close to the inner solar system. Why call it the 12th? Sitchin pointed to Sumerian astronomy, where they counted the sun and moon as planets in their celestial lineup. He interpreted their texts as describing Nibiru as the homeworld of the Anunnaki, a race of advanced beings who looked a lot like us but were basically gods in human eyes. These Anunnaki, he claimed, came to Earth around 450,000 years ago, splashing down in the Persian Gulf. They weren't here for a vacation, they needed gold. Not for jewelry, but to fix their planet's atmosphere. Nibiru's orbit takes it so far from the sun that it gets freezing cold, and they used gold particles to reflect heat or something like that. Mining gold themselves was tough, so about 300,000 years ago, they genetically engineered humans from early hominids to do the dirty work. Yeah, you heard that right. We're basically slave labor upgraded with alien DNA, according to Sitchin. He backed this up with his readings of Sumerian myths, like the Epic of Creation, or Enuma Elish, which talks about a battle between gods that led to Earth's formation. Sitchin saw this as a cosmic collision, Nibiru smashing into a planet called Tiamat, splitting it into Earth and the asteroid belt. One of Nibiru's moons hit Tiamat, creating our moon from the debris. It's a dramatic retelling that ties into the Bible too. Sitchin linked the Anunnaki to the Nephilim, those giants mentioned in Genesis, who came down and mingled with humans. He even suggested the Great Flood was caused by Nibiru's gravity pulling on Earth's ice caps during a close pass, melting them and causing worldwide deluge. Now, this all sounds pretty out there, but Sitchin's books sold millions, and his ideas caught fire in the New Age and conspiracy communities. People loved the notion that ancient astronauts shaped our world. It explained pyramids, Stonehenge, and all those megalithic structures that seemed too advanced for primitive tools. But here's where it gets apocalyptic. If Nibiru swings by every 3,600 years, what's the schedule? Sitchin calculated the last visit around 1600 before the Common Era, during biblical times, maybe tying into the Exodus plagues. That means the next one could be any time now, depending on who you ask. Some followers pegged it to 2003, then pushed it to 2012 when nothing happened. 2012, that's when Nibiru really hit the mainstream panic button. Remember the Mayan calendar frenzy? The long count calendar supposedly ended on December 21st, 2012, and doomsayers linked it straight to Nibiru. They said the Mayans knew about this rogue planet from their own ancient knowledge, maybe passed down from the same alien visitors. Books, websites, and even a blockbuster movie called 2012 fueled the hype, showing Earth cracking apart from gravitational forces. People built bunkers, stocked up on canned goods, and waited for the end. Conspiracy theorists claimed NASA was hiding telescope images of Nibiru approaching, disguising it as a comet, or just denying its existence outright. But guess what? December 21st came and went. No massive planet loomed in the sky, no global cataclysm wiped us out. The world kept spinning, and the only disasters were the usual ones. Earthquakes, storms, nothing out of the ordinary. Mayan scholars had been saying all along that the calendar didn't predict doom. It just rolled over like our calendars do at the end of the year. It was more about cycles of renewal than apocalypse. Still, the failure didn't kill the theory. Believers just recalculated, saying the alignment was off, or that Nibiru's effects were subtler, like increased natural disasters. Take 2017, for example. A numerologist named David Meade stirred up fresh panic with his book Planet X, the 2017 arrival. He tied Nibiru to biblical prophecies in Revelation, claiming it would appear on September 23rd, causing massive eclipses, earthquakes, and tsunamis. Meade pointed to recent hurricanes like Harvey and Irma as signs of Nibiru's influence, its gravity already tugging at Earth from afar. Social media exploded with videos of two suns in the sky, probably lens flares or atmospheric tricks, but folks swore it was Nibiru peeking out. Again, NASA stepped in, with scientists like David Morrison explaining there's no such planet. If something that big was coming, we'd see it with naked eyes months in advance, and telescopes worldwide would spot it years ahead. NASA has been debunking Nibiru for decades. Back in 2009, they put out videos and articles saying there's no Planet X hurtling toward us. Don Yeomans, a planetary scientist, pointed out that gravitational effects from such a body would mess with other planets' orbits, and we'd detect that easily. Their Wide-Field Infrared Survey Explorer telescope scanned the skies and found nothing Neptune-sized beyond Pluto. In 2012, they even had a Why the World Didn't End Yesterday page, addressing Nibiru directly. If Nibiru were real, they said, it would be tracked by thousands of astronomers, amateur and professional. But conspiracy folks flip that around. NASA's in on the cover-up, hiding data to prevent mass panic. Why the secrecy? That's where the theories get even wilder. Some say world governments know about Nibiru and are building secret bunkers for the elite. Think Denver Airport's underground facilities or seed vaults in Norway. Others link it to global warming. Yeah, you heard right. Climate change is a hoax, they claim, cooked up to explain away Nibiru's effects. Rising temperatures, melting ice, extreme weather, it's all from this approaching planet's pull, not carbon emissions. Conspiracy sites argue that scientists are paid to push the man-made warming narrative, distracting us from the real threat. Hurricanes intensifying, Nibiru's fault, earthquakes on the rise, same deal. It's a way to control the population, they say, with carbon taxes and regulations while the powerful prepare to survive. But let's balance this out. Mainstream science calls Sitchin's translations bunk. Experts in Sumerian like Michael Heiser have picked apart his work, saying he misunderstood basic words. Nibiru in Babylonian astronomy means a crossing point or Jupiter when it's at certain positions, not a rogue planet. The Anunnaki were gods, not aliens, and the epic of creation is mythology, not astrophysics. No artifacts show advanced tech from visitors. It's all consistent with Bronze Age cultures. And those doomsday dates? They flopped repeatedly. 2003 was supposed to be it. Sitchin himself distanced himself from predictions, but fans ran with it. When nothing happened, they moved to 2012, then 2017, and even April 23rd, 2018, tying it to more biblical stuff. Each time, the world chugs on. Still, you can't deny the appeal. In a world full of uncertainty, pandemics, wars, climate shifts, it's comforting in a twisted way to blame a cosmic boogeyman. It gives meaning to chaos, suggests we're part of a bigger story, and who knows? Astronomers do talk about a possible Planet 9 way out there, based on orbital oddities in the Kuiper Belt. But that's a hypothetical ice giant, not a civilization-destroying behemoth on a collision course. Caltech's Mike Brown and Konstantin Batygin proposed it in 2016, estimating it's 10 times Earth's mass with a 20,000-year orbit, nothing like Nibiru. So, as we wrap our heads around this horrifying yet fascinating theory, it ties back to those cycles of catastrophe we touched on with Atlantis and the floods. If Nibiru exists, its passes could explain mass extinctions, ice ages, and lost civilizations every few millennia. But evidence points to it being more myth than menace. Still, the idea lingers, whispering that maybe, just maybe, something's out there in the dark, waiting to swing by again. That leads us right into the next puzzle, the Younger Dryas event, a sudden freeze that might have buried ancient wonders under ice and waves. What if a comet strike, not a planet, was the culprit? As we ponder signs today, rising flares, asteroid watches, could the next disaster be brewing? Drop a note below about the spot on the globe you're listening from, and what's the hour striking where you are while we stare down these stellar perils. This sets the stage for modern omens and future forecasts. Let's explore where we stand in this cycle of chaos next. 12,800 years ago, the world was thawing out from the grip of the last ice age. Glaciers were retreating, temperatures rising, and early humans were starting to settle into a warmer, more forgiving planet. Then, out of nowhere, bam, a cosmic hammer strike. A comet fragments streak across the sky, exploding in airbursts over North America and beyond, igniting wildfires that scorch continents, melting ice sheets in a flash flood of biblical proportions, and plunging the Earth back into a mini ice age. Mammoths drop dead in their tracks, entire species vanish, and any budding civilizations, wiped clean, their secrets buried under layers of sediment and time. This is the Younger Dryas event, a mysterious cold snap that lasted over 1,000 years, and the impact hypothesis that suggests it wasn't just bad luck, it was a catastrophe from the stars. What if this wasn't random? What if it erased a forgotten chapter of human history, leaving us to piece together the puzzle from scattered clues? Buckle up, because we're about to uncover the enigmas of the past that still whisper warnings to us today. Let's start with the basics of the Younger Dryas itself, named after a hardy Arctic flower that thrived during this chilly period. Picture the scene. Around 14,700 years ago, the planet was emerging from the Pleistocene epoch, the height of the Ice Age. Massive ice sheets covered much of North America and Europe, but as the world warmed, sea levels rose, and human hunter-gatherers roamed freer. Then, abruptly, between 12,900 and 11,700 years ago, temperatures plummeted by as much as 18 degrees Fahrenheit in some places. Greenland ice cores show this drop happened in just a few decades, maybe even years. Summers turned harsh, winters deadly, and the progress toward agriculture and settled life hit a wall. Why? For years, scientists pointed to natural causes, like a slowdown in the ocean's thermohaline circulation, the great conveyor belt that carries warm water from the equator to the poles. Massive fresh water from melting glaciers poured into the North Atlantic, disrupting this flow and cooling the northern hemisphere. But then came the impact hypothesis, a theory that's equal parts thrilling and terrifying. First proposed in 2007 by a team of researchers, including Richard Firestone and Alan West, it suggests that one or more comets, or perhaps fragments of a larger one, slammed into or exploded above Earth around 12,800 years ago. These weren't gentle visitors. Imagine airbursts with the force of nuclear bombs, scattering debris across continents. The explosions would have triggered massive fires, blanketing the sky in soot and blocking sunlight, which explains the sudden cooling. At the same time, The heat could have destabilized ice dams, unleashing floods that reshaped landscapes and raised sea levels by feet in a matter of months. This isn't just speculation. Evidence has been piling up from sites across North America, Europe, and even the Middle East. Take the black mat layer, for instance, a dark, organic-rich sediment found in over 70 locations from Canada to Syria. This layer dates precisely to the start of the Younger Dryas and contains markers of catastrophe. High levels of iridium, a rare element common in extraterrestrial objects, nanodiamonds formed under extreme pressure and heat, and magnetic microspherules, tiny glass-like beads created when rock melts and cools rapidly. In 2024, a study from the University of California, Santa Barbara, analyzed quartz grains from sites in New Jersey, Maryland, and South Carolina, finding shock lamellae microscopic fractures caused by intense impacts. These aren't from volcanoes or everyday fires, they're signatures of cosmic violence. Another recent find? Platinum spikes in Greenland ice cores and sediment from South Carolina, peaking right at the Younger Dryas boundary. Platinum is another cosmic hitchhiker, rare on Earth but plentiful in comets. And the comet itself? Estimates suggest it was about 62 miles wide, breaking into pieces that rained down over a wide area. One key site is the Hiawatha crater in Greenland, discovered in 2018 under a mile of ice, a 31-kilometer wide scar that dates to around the same time. While not definitively linked, it fits the puzzle. Critics argue there's no single massive crater, but proponents say airbursts, explosions high in the atmosphere wouldn't leave one, just widespread debris. This theory also ties into the end Pleistocene megafaunal extinctions. Over 35 genera of large animals, like woolly mammoths, saber-toothed tigers, and giant ground sloths, vanished around this period. Was it overhunting by humans? Climate alone? Or did the impacts and their aftermath deliver the knockout blow? Now, here's where it gets really intriguing and a bit controversial. Enter Graham Hancock, a journalist and author who spent decades chasing the ghosts of lost civilizations. Hancock isn't your typical historian. He's a storyteller who weaves science, mythology, and bold hypotheses into narratives that challenge everything we think we know. In books like Fingerprints of the Gods from 1995 and his Netflix series Ancient Apocalypse from 2022, Hancock argues that the Younger Dryas wasn't just a climate hiccup, it was the death knell for an advanced Ice Age civilization. Picture this. Before the floods and freezes, humans had built sophisticated societies with knowledge of astronomy, engineering, and navigation. They weren't cavemen. They were seafarers and stargazers, perhaps even mapping the globe. Then the comet hits, triggering cataclysms that sink their coastal cities and scatter survivors, who pass on fragments of their wisdom to emerging cultures like the Egyptians and Sumerians. Hancock points to anomalies that don't fit the standard timeline. Why do ancient maps like the Piri Race from 1513 show Antarctica's coastline without ice, as if drawn from observations 12,000 years ago? How did the Egyptians build the pyramids with such precision if they were just starting out? He links these to the Younger Dryas impacts, suggesting the catastrophe reset human progress. Critics, and there are many, call this pseudoscience. The Society for American Archaeology even urged Netflix to label Ancient Apocalypse as fiction, arguing it discredits real research and promotes white supremacist ideas by implying non-European cultures needed outside help to advance. But Hancock fires back, saying mainstream archaeology is too rigid, ignoring evidence that doesn't fit their narrative. What if he's onto something? What if the Younger Dryas hid a lost world? No site embodies this mystery more than Göbekli Tepe, a hilltop sanctuary in southeastern Turkey that rewrites the book on human history. Discovered in 1994 by German archaeologist Klaus Schmidt, this isn't just old, it's 11,600 years old, predating Stonehenge by 6,000 years and the pyramids by 7,000. Imagine stumbling upon massive T-shaped pillars, up to 20 feet tall and weighing tons, carved with intricate animals, foxes, boars, birds, even abstract symbols that might represent comets or stars. These aren't crude scratches, they're sophisticated reliefs, arranged in circular enclosures that look like temples. But here's the mind-blower. Göbekli Tepe was built by hunter-gatherers, before agriculture, before pottery, before metal tools. How? Schmidt estimated hundreds of people labored here, quarrying stone from nearby hills and hauling it without wheels or beasts of burden. The site's significance? It flips the Neolithic revolution on its head. We used to think farming led to settled life, which led to religion and complex societies. But Göbekli Tepe suggests the opposite. Spiritual needs drove people to gather, build, and eventually farm to sustain these gatherings. Some pillars depict what look like handbags or celestial events, fueling speculation. Hancock sees it as evidence of a pre-flood civilization's survivors teaching locals advanced knowledge. Recent finds, like a 12,000-year-old statue embedded in a wall, a life-sized human figure with a painted face, hint at ritual burials or guardians. And the site was deliberately buried around 10,000 years ago, not by natural disaster, but by humans filling it with debris. Why hide it? To protect sacred knowledge from the next catastrophe. This burial ties into broader mysteries, like why similar megalithic sites pop up worldwide around the same time. From Malta's temples to Peru's Caral, it's as if a shared blueprint survived the younger Dryas. And what about the Bermuda Triangle? That infamous stretch of Atlantic between Florida, Bermuda, and Puerto Rico, where ships and planes vanish without trace. Over the years, hundreds of disappearances, Flight 19 in 1945, the USS Cyclops in 1918, have sparked tales of portals, alien bases, or lost Atlantean tech. Skeptics blame human error, storms, or methane gas bubbles from the seafloor disrupting buoyancy, but could it connect to ancient catastrophes? Some theorists suggest magnetic anomalies from the younger Dryas impacts linger there, messing with compasses and electronics. Or perhaps submerged ruins from a pre-flood civilization emit energy fields. A 2024 expedition found unusual underwater formations, but nothing conclusive. It's a stretch, but it adds to the intrigue. What if the triangle is a scar from the same event that froze the world? Of course, digging into these ideas often leads to conspiracy territory. Why haven't we found more evidence of lost civilizations? Some say governments and institutions are hiding it. Take the Smithsonian Institution. Rumors persist. They've suppressed giant skeletons or anomalous artifacts to uphold Darwinian evolution and linear history. Hancock accuses academia of gatekeeping, ignoring sites like Gunung Padang in Indonesia, which he claims dates to 20,000 years ago with advanced construction. Critics debunk this, but the pattern holds. New discoveries threaten textbooks, so they're dismissed. In 2022, Netflix's Ancient Apocalypse sparked backlash, with archaeologists calling it dangerous for spreading misinformation that could fuel extremism. Yet, believers argue suppression keeps power in check. If we knew about advanced ancients, it might upend religions, economies, even our sense of progress. What if the younger Dryas was a cycle's punctuation mark, erasing one era to birth another? The evidence tantalizes. Cosmic markers, buried temples, vanishing zones. It makes you wonder what secrets lie under our feet, waiting for the next thaw. This cosmic drama sets the stage for Earth's own rhythms, like the Milankovitch cycles that dance with our orbit and tilt, driving ice ages over millennia. Let's turn the page to those scientific beats next and see how they pulse through our planet's story. Have you ever stopped to think about how the Earth isn't just spinning like a top in space, it's dancing a slow, intricate waltz with the sun, one that shapes everything from scorching summers to bone-chilling winters over vast stretches of time? Back in the early 1900s, a Serbian mathematician named Milutin Milankovitch sat in a quiet room, scribbling equations that would unlock one of the biggest puzzles in our planet's history. Why do ice ages come and go like clockwork? He wasn't out in the field digging up fossils or trekking across glaciers. He was crunching numbers, piecing together how tiny shifts in our orbit could trigger massive freezes that blanket continents in ice. And get this, his ideas, once dismissed as too out there, now form the backbone of how we understand these grand cycles. But what if these predictable patterns hold clues to even wilder disruptions, like the floods and vanishes we've been chasing? Let's follow Milankovitch's trail and see where it leads us through the rhythms of our world. Milankovitch was no ordinary thinker. Born in 1879 in what was then the Austro-Hungarian Empire, he grew up fascinated by the stars and the math that governed them. By the time World War I rolled around, he found himself a prisoner of war, but even then, he convinced his captors to let him work on his theories. instead of hard labor. Picture him in a makeshift library on a Hungarian island, poring over astronomical data while the world outside was in chaos. He built on ideas from earlier scientists like James Kroll and Joseph Adamar, who had toyed with notions of orbital changes affecting climate. But Milankovitch took it further, calculating precisely how 3 key variations in Earth's path around the Sun could amplify or dampen the sunlight hitting our poles. These aren't random wiggles. They're like the gears in a cosmic clock, ticking away over tens of thousands of years. First up is eccentricity, the fancy word for how Earth's orbit stretches from a near-perfect circle to more of an oval shape. Right now, our path is pretty round, with the difference between closest and farthest points from the Sun being only about 3%. But over a cycle of roughly 100,000 years, that oval gets more pronounced, up to about 5%. When it's more elliptical, the seasons get more extreme. Summer's hotter when we're closer to the Sun, winter's colder when we're farther out. Milankovitch figured that during these stretched-out phases, the overall solar energy reaching Earth dips just enough to tip the scales toward cooling, especially if it lines up with other factors. It's subtle, maybe a 1% change in total sunlight, but over millennia, that adds up, like a slow drip filling a bucket until it overflows into an ice age. Then there's obliquity, or the tilt of Earth's axis. Today, we're tilted at about 23.5 degrees, which is why we have seasons at all. The reason summer in the northern hemisphere means the North Pole leans toward the Sun, soaking up rays, while the South Pole chills in darkness. But this tilt isn't fixed. It wobbles between 22 and 24.5 degrees over a 41,000-year cycle. When the tilt is steeper, seasons are more intense. Hotter summers, colder winters. A shallower tilt means milder everything, with less contrast. Milankovitch realized that a reduced tilt means weaker summer sun at high latitudes, not enough to melt the previous winter's snow. Leftover ice builds up year after year, reflecting more sunlight away and cooling things further in a feedback loop that snowballs, pun intended, into vast ice sheets. Rounding out the trio is precession, the slow wobble of Earth's axis like a spinning top losing steam. This cycle takes about 26,000 years, and it changes which star the North Pole points toward. Right now it's Polaris, but in ancient times it was different, which is why Egyptian pyramids align with stars from their era. Precession flips the seasons relative to our closest approach to the Sun. Sometimes summer in the north happens when Earth is farthest from the Sun, cooler summers. Sometimes when it's closest, warmer ones. When precession sets up cooler northern summers, it again favors ice buildup, especially in places like Canada and Scandinavia, where glaciers love to form. Milankovitch wove these 3 cycles together in his calculations, showing how they overlap and reinforce each other at certain points, creating windows for ice ages every 100,000 years or so. He published his big work in 1924, but it took decades for the scientific community to catch on. Skeptics pointed out that the changes in sunlight seemed too small to cause such huge shifts. But then came deep-sea sediment cores in the 1970s, pulled from ocean floors around the world. These muddy time capsules, layered like tree rings, revealed oxygen isotope patterns that matched Milankovitch's predictions to a T, peaks and valleys in temperature syncing with those orbital dances. It was like finding the smoking gun, proof that these cycles drive the pulse of our climate over long hauls. Now, let's zoom in on the last big ice age, the one that wrapped up about 11,700 years ago. During its peak, around 21,000 years ago, ice sheets 2 miles thick covered North America down to New York City, and Europe was a frozen tundra where woolly mammoths roamed. Sea levels were 390 feet lower because so much water was locked up in ice, exposing land bridges like the one between Siberia and Alaska that let early humans cross into the Americas. Milankovitch's math shows this glacial maximum happened when all 3 cycles aligned for minimal summer sun in the north, high eccentricity making orbits wonky, low obliquity muting seasons, and precession putting northern summers at the far end of the orbit. As the cycles shifted, more sunlight hit the poles, melting kicked in, and the world warmed into our current interglacial period, the Holocene, where we've built civilizations without dodging glaciers. But here's where curiosity pulls us deeper. These cycles don't just explain ice. They might tie into those ancient floods we've heard whispers about. As ice melted rapidly at the end of the last age, massive lakes like Agassiz in North America burst their dams, dumping fresh water into oceans and triggering sea level rises of feet per century. Could this be the real root of global flood myths? In places like the Black Sea, which was a freshwater lake until rising Mediterranean waters breached it around 7,500 years ago, entire villages might have been submerged overnight. Divers have found drowned settlements there, complete with wooden structures, echoes of lost worlds that fuel tales of deluge. And think about Doggerland, the now sunken land between Britain and Europe, a lush plain inhabited by Stone Age people until waves claimed it. Artifacts dredged from the North Sea tell stories of hunters who watched their homes vanish. Milankovitch's work also sparks questions about feedback loops that amplify these orbital nudges. For instance, when ice expands, it reflects more sunlight, the albedo effect, cooling the planet further. Dust from exposed land blows into the atmosphere, blocking sun. Volcanoes might erupt more during glacial stresses, adding aerosols that chill things. On the flip side, warming releases greenhouse gases from thawing permafrost and oceans, speeding the melt. These aren't in Milankovitch's original equations, but modern models layer them on, showing how a small orbital push can cascade into full-blown ice ages. It's like Earth's climate is a sensitive orchestra, with orbits as the conductor waving a subtle baton. Peering further back, these cycles explain the Pleistocene epoch's rhythm of about 20 ice ages over 2.5 million years. Before that, in the Pliocene, Earth was warmer, with no northern ice caps perhaps because continents were positioned differently or CO2 levels were higher, overriding the orbital signals. But around 3 million years ago, as Panama's isthmus closed and ocean currents shifted, the stage was set for Milankovitch to take charge. Each cycle leaves marks. In Antarctic ice cores spanning 800,000 years, bubbles trap ancient air showing CO2 dips during glacials. In Chinese loess deposits, wind-blown soil layers thicken in cold times. What keeps this fascinating is how it intersects with human history. Our species, Homo sapiens, evolved during these swings, adapting to freezes that pushed us out of Africa around 70,000 years ago during a glacial dip. Cave paintings in France and Spain from 30,000 years back depict animals thriving in icy landscapes, bison, horses, even woolly rhinos. Were these artists witnessing the tail end of a Milankovitch-driven cold spell? And as the last ice age thawed, agriculture sprouted in the Fertile Crescent around 10,000 years ago, kick-starting civilizations. Without that orbital shift toward warmth, who knows if we'd have pyramids or cities? Yet, Milankovitch raises eyebrow-raising what-ifs for our future. We're in an interglacial now, but the cycles predict another cooling in about 50,000 years, though human-driven warming might overpower it, delaying the next ice age by tens of thousands of years. Some wonder if ancient observers notice these patterns. Stonehenge's alignments track solstices, perhaps monitoring precession. Mayan calendars span long counts that echo orbital timescales. Could lost knowledge of these cycles be hidden in myths, warning of inevitable returns to ice? These rhythms reveal a planet that's anything but static. It's a living, breathing entity swayed by celestial mechanics. But orbits aren't the only beat. Deeper forces like mass extinctions and magnetic flips add layers to Earth's deadly drum. If this cosmic dance has you hooked and you're ready for the next pulse, slip a quick subscribe and tap that bell, your quiet way of staying tuned to the whispers of history while the night deepens. What if those pulses sync up to create even bigger bangs? Let's chase that rhythm next and uncover the heartbeat that could stop life in its tracks. Ever wonder what it would feel like to witness the end of almost everything alive on Earth, not in a flash, but in a grinding, inescapable wave that erases species after species, leaving ghosts in the fossil record? That's the chilling reality of mass extinctions, those rare but devastating resets in our planet's history where life gets dialed back to basics. And lurking beneath the surface, literally, is another pulse, the flipping of Earth's magnetic poles, a geomagnetic reversal that could strip away our invisible shield against the cosmos. What if these two phenomena aren't just separate drumbeats in Earth's deadly symphony? What if they sync up, amplifying each other into a rhythm of destruction? Mass extinctions aren't your everyday die-offs. They're global catastrophes, where at least 3/4 of species vanish in a geological blink, sometimes over millions of years, other times in mere millennia. Scientists have pinpointed 5 major ones over the past 540 million years, each a chapter in Earth's brutal biography. The first big one hit during the Ordovician-Silurian transition, around 444 million years ago. Picture a world dominated by oceans teeming with bizarre invertebrates, trilobites scuttling on seafloors, nautiloids jetting through water like living rockets. Then, bam! 2 pulses of extinction wipe out 85% of marine species. What sparked it? Likely a combo of falling sea levels from expanding glaciers, sucking oxygen from shallow waters, and maybe a gamma-ray burst from a distant star, frying the ozone layer. Fossils from this era show reefs collapsing, entire ecosystems turning to sludge. It's like the ocean's party ended abruptly, leaving empty shells as tombstones. Fast forward about 72 million years to the late Devonian extinction, stretching from 372 to 359 million years ago. This one unfolded in fits and starts, hammering marine life again, 75% gone, including those armored fish that looked like underwater tanks and the first forests on land. Coral reefs, which had just started booming, got decimated. Placoderms, the jawed giants of the seas, mostly vanished. Theories point to massive volcanic eruptions in what's now Siberia, pumping out greenhouse gases that warmed the planet, only to trigger anoxic events where oceans turned toxic with low oxygen. Asteroid impacts might have played a role too, with craters like the Siljan in Sweden dating to this time. Imagine standing on a prehistoric shore, watching fish gasp at the surface as black, sulfurous waters roll in nature's way of saying reset. But if those were bad, the Permian-Triassic event around 252 million years ago takes the crown as the Great Dying. 96% of marine species and 70% on land poof. This was the closest life came to winking out entirely. Trilobites, those survivors of earlier wipes, finally bit the dust. Forests of Glossopteris trees turned to coal seams. Even insects, usually tough as nails, suffered their only mass extinction. The culprit? The Siberian Traps, a volcanic province that spewed lava over an area the size of Europe for 1 million years, releasing enough carbon dioxide to superheat the planet by 18 degrees Fahrenheit. Oceans acidified, killing shell builders. Toxic hydrogen sulfide bubbled up, poisoning air and water. Fossils from this boundary show a fungal spike, mushrooms thriving on rotting corpses worldwide. What secrets do those layers hold? Did a methane release from thawing permafrost push it over the edge, creating a runaway greenhouse hell? The Triassic-Jurassic extinction 201 million years ago cleared the stage for dinosaurs to dominate. About 80% of species gone, including many archosaurs and large amphibians. Central Atlantic magmatic province volcanoes erupted as Pangaea split, belching gases that caused rapid warming and ocean acidification. Conodonts, eel-like creatures key to dating rocks, disappeared. Therapsids, our mammal-like ancestors, took a hit. It's curious right after, dinosaurs exploded in diversity, as if the extinction was evolution's cruel editor, cutting the old to make way for the new. Fossils from Nova Scotia show footprints of early dinos stepping over the bones of the fallen. Finally, the Cretaceous-Paleogene event, 66 million years ago, the one that dethroned the dinosaurs. An asteroid 10 miles wide smashed into the Yucatan Peninsula, creating the Chicxulub crater and triggering tsunamis, wildfires, and a nuclear winter from dust blocking the sun. 75% of species extinct, including all non-avian dinos, pterosaurs, and marine reptiles like mosasaurs. Ammonites, those spiral-shelled icons, vanished. Plankton at the base of the food chain crashed. Volcanism from India's Deccan Traps might have weakened ecosystems beforehand, adding acid rain and mercury poisoning. Iridium layers worldwide scream space rock, but the combo of impacts and eruptions paints a picture of a planet under siege from above and below. Now, here's what piques the curiosity. These aren't random. Paleontologists spotting patterns in the fossil record suggest a 27 million year cycle for mass extinctions, especially those hitting land animals. A study from New York University in 2020 analyzed extinctions of amphibians, reptiles, mammals, and birds, finding they cluster every 27.5 million years, coinciding with major asteroid impacts and volcanic floods. The last peak was about 7 million years ago, not a full extinction, but notable die-offs. Why this rhythm? One theory ties it to our solar system's bob through the Milky Way's plane every 30 million years or so, stirring up comets from the Oort cloud that pelt Earth. Or perhaps dark matter clumps in the galaxy trigger geological unrest. We're about 19 million years into the current cycle. Does that mean we're overdue for trouble? Or safe for another 8 million? Shifting gears to the geomagnetic side, Earth's magnetic field is like an invisible force field, generated by swirling molten iron in the outer core, deflecting solar wind and cosmic rays that would otherwise strip our atmosphere and fry life. But it's not eternal. It flips polarity, north becomes south, south-north, in geomagnetic reversals. These happen irregularly, averaging every 200,000 to 300,000 years, though gaps can stretch to tens of millions. The last full flip, the Brunhes-Matuyama reversal, was 780,000 years ago. Before that, the field was reversed for millions of years during the Matuyama Chron. How does a reversal unfold? The field weakens over thousands of years, dropping to 10% strength. Multiple poles might wander, and then it snaps back in the opposite direction. During the transition, which can take 1,000 to 10,000 years, protection wanes. More charged particles penetrate, boosting auroras, but also mutation rates from radiation. Fossils and lava flows preserve these flips. Magnetic minerals align with the field when rock solidifies, creating striped patterns on ocean floors from seafloor spreading. The big question: do reversals spell doom? Alone, probably not hundreds have occurred without wiping life out, but timing raises eyebrows. A reversal 42,000 years ago, the Lachamp event, lasted about 1,000 years with the field at 5% strength. A 2021 study linked it to environmental chaos. Weakened ozone let UV rays in, stressing plants and animals. Cave art surged as people sheltered from solar storms. Even Neanderthals' decline might connect. In Australia, megafauna like giant kangaroos vanished around then, and tree rings show carbon spikes from cosmic rays. Deeper back, the Ediacaran period 550 million years ago saw hyperactive field flips up to 26 per million years, coinciding with the first mass extinction of soft-bodied creatures. A 2015 study suggested rapid reversals shredded ozone, flooding Earth with UV that mutated or killed off Ediacarans, paving way for Cambrian explosion. Another theory: impacts could trigger reversals by shocking the core, like a hypothesized comet at the Permian boundary. But connections to the Big Five? Mixed bag. The Permian-Triassic lines up loosely with a reversal cluster, and oxygen escape during weak fields might explain atmospheric drops. A 2014 paper proposed that without a strong field, solar wind strips oxygen, linking to extinctions. Yet USGS states no direct correlation. Reversals are too frequent for rare extinctions. Reddit debates echo this. Hundreds of flips, only 5 majors, so probably coincidence. Still, if a reversal hits during volcanic or impact stress, it could amplify weak field, lets more radiation in, stressing already fragile ecosystems. What fuels the flips? Core convection slows or disrupts, perhaps from mantle plumes or subduction. Recent data shows the field weakening 10% since 1840, with the South Atlantic anomaly growing a dent where radiation leaks in, zapping satellites. Is a flip brewing? Models say maybe in 1,000 years, but signs like accelerating pole drift from Canada towards Siberia at 30 miles per year keep scientists watching. A 2025 CNN report updated the magnetic north position, noting flips happen every million years on average. But our overdue status sparks worry. Imagine the fallout. During a reversal, compasses spin wild, migrations confuse birds and whales, power grids fry from solar flares, cancer rates might rise from radiation. But life has survived before humans evolved through the last one. Yet with our tech-dependent world, it could be apocalyptic. Tie this to extinction cycles. If the 27 million year pulse involves galactic crossings that boost radiation, a weak field during those windows could turn bad to worse. These beats extinctions pulsing every 27 million years. Reversals flipping sporadically form Earth's deadly cadence. But the cosmos adds its own threats. Gamma bursts, supernovae, solar flares that could sync with these for ultimate wipes. What if the next alignment is closer than we think? Let's venture into those stellar perils next and see how the universe itself plots against us. A distant star, billions of times brighter than our sun, suddenly erupts in a blaze of fury, unleashing a beam of gamma rays so intense it could strip away our planet's protective shield, bathing the surface in lethal radiation and rewriting the story of life as we know it. Or imagine a supernova exploding in our cosmic neighborhood, its shockwave hurling high-energy particles across space, triggering climate chaos that echoes through millennia. These aren't just plot twists from a sci-fi thriller, they're real threats lurking in the vast darkness of the universe, unpredictable disasters that could strike without warning. As we venture beyond Earth's own rhythms of catastrophe, we enter the realm of cosmic perils. Gamma-ray bursts, supernovae, solar flares that pack a punch, asteroid barrages, and even the slow, inevitable bloating of our own sun. What secrets do these stellar spectacles hold? Could they explain ancient extinctions, hidden cycles of doom, or the fragile thread of our existence? Let's gaze into the abyss and uncover the mysteries that make the night sky both beautiful and terrifying. Gamma-ray bursts, or GRBs for short, are among the most explosive events in the universe, outshining entire galaxies for brief moments and packing more energy in seconds than our sun will emit over its entire lifetime. First detected in the late 1960s by satellites hunting for nuclear tests during the Cold War, these flashes puzzled astronomers until the 1990s, when telescopes like NASA's Compton Gamma Ray Observatory pinned them down as cosmic phenomena. There are two main types: short bursts, lasting less than 2 seconds, often from merging neutron stars, and long bursts, stretching minutes, tied to the collapse of massive stars into black holes. When a star over 20 times our sun's mass dies, its core implodes, and if it's spinning fast enough, it shoots out jets of gamma rays at nearly light speed, piercing through space like cosmic lances. What makes GRBs so intriguing and scary is their potential to wreak havoc if one points our way. From thousands of light years away, a GRB could deplete Earth's ozone layer by up to 50%, letting ultraviolet radiation flood the surface. UV rays don't just cause sunburns, they damage DNA, disrupt photosynthesis, and could collapse food chains starting with plankton in the oceans. A 2016 NASA study suggested a nearby GRB, say, within 6,000 light-years might trigger a mass extinction, sterilizing vast swaths of the planet. Imagine the sky lighting up brighter than a full moon, followed by weeks of eerie auroras as charged particles rain down. Crops fail, skin cancers skyrocket, and ecosystems teeter on the brink. But has this happened before? Some scientists think yes. The late Ordovician extinction 440 million years ago, which wiped out 85% of marine species, shows signs of UV damage in fossils, deformed spores, and pollen hinting at ozone loss. A GRB from a star in our galaxy could be the culprit, its beam hitting Earth like a death ray from the past. Recent events keep the curiosity alive. In 2023, the European Space Agency's integral satellite caught a GRB from a distant galaxy that disturbed Earth's ionosphere, the upper atmosphere layer that bounces radio waves. It was like a mini solar flare, but from billions of light-years away. And a 2015 study upped the ante, estimating a 50% chance of a devastating GRB hitting Earth in the last 500 million years. Conspiracy whispers suggest governments downplay these risks after all. What can we do against a beam from the stars? But astronomers scan the skies with telescopes like Swift and Fermi, hunting for bursts to understand their patterns. One theory ties GRBs to the galaxy's structure. Stars in dense arms might burst more often, and as our solar system orbits the Milky Way every 230 million years, we dip through riskier zones. Could this explain periodic extinctions? It's a tantalizing puzzle, blending astrophysics with paleontology. Shifting our gaze to supernovae, those stellar fireworks mark the violent deaths of massive stars, exploding with the force of billions of nuclear bombs and scattering elements like iron and gold across space, the very stuff that built our planet and bodies. Type 2 supernovae come from stars 8 to 50 times our sun's mass, collapsing and rebounding in a shockwave that lights up the sky. Type Ia, meanwhile, involve white dwarfs siphoning material from companions until they detonate like cosmic thermonuclear bombs. Historical records brim with sightings. The Chinese noted a guest star in 1054, now known as the Crab Nebula remnant. Tycho Brahe spotted one in 1572, shaking European views of an unchanging heavens. But beauty hides danger. A supernova within 30 light-years could bombard Earth with cosmic rays, high-energy protons, and nuclei accelerating to near-light speed, penetrating our atmosphere and boosting mutation rates or causing cancer spikes. Even at hundreds of light-years, the radiation might erode ozone, letting UV in and altering climate. A 2019 Astronomy.com article pondered how supernovae have shaped life. A nearby blast could rain muons, secondary particles that reach the ground, disrupting biology. Recent research from 2025 links supernovae to at least 2 mass extinctions. Iron 60 isotopes in ocean sediments forged only in supernovae spike around 2 to 3 million years ago and 8 million years back, coinciding with cooling periods and die-offs. These blasts, perhaps from stars like Betelgeuse, 640 light-years away and poised to explode someday, could have zapped methane in the atmosphere, a greenhouse gas, triggering abrupt cools. A June 2025 study suggests supernovae nudged Earth's climate into sudden shifts, with radiation degrading stratospheric methane and ozone, leading to cooling and ecological stress. Visible light from a supernova would shine like a second moon for months, but the real threat is the particle onslaught lasting centuries. Late Quaternary supernovae left traces in tree rings, carbon-14 spikes, and might have influenced human evolution, pushing ancestors into caves for shelter. With Betelgeuse dimming erratically, astronomers wonder if its supernova could affect us, likely not lethally, but enough to scramble satellites and power grids. Tying these to cycles, Earth's 27.5 million-year heartbeat of geological upheavals, mass extinctions, volcanic floods, sea level changes, might stem from cosmic influences. A 2021 study analyzed 260 million years of events, finding clusters every 27.5 million years. Why? As our solar system bobs through the galactic plane every 30 million years, it stirs Oort cloud comets or encounters dark matter clumps, triggering impacts or core disruptions. Volcanic eruptions and extinctions align with this pulse, perhaps amplified by supernovae or GRBs in denser star regions. We're midway through a cycle last peak 7 million years ago, so the next beat might loom in 20 million years. But smaller events could strike sooner. Don't overlook our own sun's tantrums. High-energy solar flares and coronal mass ejections, CMEs. These eruptions hurl plasma at Earth, causing geomagnetic storms that fry electronics. The Carrington event of 1859 lit telegraphs on fire and painted auroras worldwide. Today, it could cost trillions in blackouts. A recent European simulation modeled a triple-threat flare, CME, particles wiping out satellites and grids. With solar maximum in 2025, risks rise. Superflares from sun-like stars suggest our sun could unleash monsters every millennium. Radiation boosts from flares pose health risks to astronauts and flyers. Asteroids add immediate peril. Chicxulub's hit 66 million years ago doomed dinosaurs. NASA tracks near-Earth objects, NEOs, with none posing threats soon, but a 1-kilometer rock could devastate globally. A 100-kilometer behemoth might end humanity. Missions like DART test deflection, but cosmic cycles might increase impacts during galactic crossings. Far future. In 5 billion years, the sun expands into a red giant, boiling oceans and engulfing Earth. Before that, increasing luminosity might sterilize us in 1 billion years. But interstellar visitors like Comet 3I, Atlas, remind us of surprises, though no threats now. These cosmic threats weave a tapestry of wonder and dread, linking stars to Earth's fate. Before we step into those modern omens, pause for a breath and tell me in the comments, where in the world are you drifting off to this story from? And what time does the clock show on your side of the planet right now? Your corner of the night sky might just hold the next clue. This sets the stage for modern omens and future forecasts. Let's explore where we stand in this cycle of chaos next. record-breaking hurricanes slamming coastlines, wildfires devouring entire towns in hours, glaciers carving into the sea like they're racing to vanish. Are these just the chaotic blips of a warming world, driven by human excess? Or are they the opening notes of something far older and more relentless, a cosmic or geological cycle gearing up for its next devastating crescendo? We've journeyed through ancient floods, rogue planets, comet strikes, orbital waltzes, extinction pulses, magnetic flips, and stellar explosions that could rewrite life in an instant. Now, let's bring it home. What do the signs of today tell us about where we sit in these grand loops? Are we teetering on the edge of a reset, or riding a wave of renewal? The clues are everywhere, from melting ice to elite bunkers, failed prophecies to cutting-edge warnings. Strap in as we decode the modern omens and peer into the uncertain tomorrow, piecing together a puzzle that might just reveal our place in Earth's unending rhythm of ruin and rebirth. Start with the elephant in the room: climate change. It's not subtle anymore. Global temperatures have climbed about 2 degrees Fahrenheit since the late 1800s, with the last decade the hottest on record. Sea levels rise 6 to 8 inches since 1900, swallowing coastlines and salinizing farmland. Extreme weather? It's the new normal. Hurricanes like Ida in 2021, dumping rain measured in feet, not inches. Heat domes baking the Pacific Northwest to 121 degrees that same summer. But here's where curiosity creeps in. Is this all us? Or is Mother Earth amplifying our mess with her own cycles? Remember Milankovitch, we're in a warm interglacial phase that should peak soon, naturally tipping toward cooling in thousands of years. Yet human greenhouse gases are overriding that, potentially delaying the next ice age by 50,000 years or more. Some scientists whisper that we're pushing the system into a hothouse state unseen for millions of years, echoing the Permian meltdown, but on steroids. Dig deeper, and patterns emerge that hint at bigger forces. Take the 27.5 million year geological heartbeat. We uncovered clusters of extinctions, massive volcanism, sea level swings. The last full thump was around 7 million years ago, with marine die-offs and cooling. We're 19 million years in, so no immediate apocalypse, but smaller echoes ripple through. Ocean sediment cores show biodiversity dips every few million years, tied perhaps to our solar system's galactic jaunts, stirring comets, or dark matter nudging the core. Today, we're seeing biodiversity crashes that rival past events. The sixth mass extinction, driven by habitat loss, pollution, overfishing but accelerated. Insect populations plummet 90% in some areas. Coral reefs bleach en masse. A 2019 UN report warned 1 million species face extinction soon. Coincidence? Or the cycle's subtle nudge, weakening ecosystems before a bigger blow? Now, zoom to shorter scales. The 12,000-year catastrophe loop, Graham Hancock champions, linked to younger Dryas-style comet swarms. If his timeline holds, the last hit 12,800 years ago, melting ice and flooding coasts. We're overdue by centuries if it's strict, but flexible interpretations point to ongoing effects. Solar activity cycles every 11 years, with grand minima like the Maunder in the 1600s causing mini ice ages. We're exiting a maximum now, but some predict a grand minimum soon, cooling us amid warming, confusing signals that mask the true trend. Magnetic field weakening? It's down 15% in 2 centuries. Poles drifting faster. The Lachamp excursion 42,000 years ago flipped briefly and stressed life. If a full reversal brews in the next millennium, radiation spikes could compound UV damage from ozone holes we're already patching. Conspiracy angles add spice. Many see elite preparations as proof we're in the danger zone. Billionaires like Jeff Bezos and Mark Zuckerberg buy remote New Zealand estates with underground shelters. Companies like Vivos build luxury bunkers for the 1%. A 2017 New Yorker piece detailed Silicon Valley preppers stocking doomsday compounds, citing risks from AI to asteroids, but whispers tie it to insider knowledge of cycles. Hancock claims archaeologists suppress ancient tech evidence to maintain control. Others say NASA hides Planet 9 data or Nibiru sightings in infrared. Failed doomsdays fuel skepticism. Harold Camping's 2011 Rapture flop. Y2K hysteria. Mayan 2012, but patterns persist. Extreme weather hoaxes circulate. Some claim hurricanes are geoengineered via HAARP to distract from pole shifts or solar flares. A viral 2024 video alleged Hurricane Helene was seeded to cover magnetic anomalies in the Appalachians. Debunked, sure, but it reflects unease. Scientific forecasts paint a mixed canvas. IPCC reports project 3 to 7 degrees warming by 2100 if emissions soar, displacing millions via floods and droughts. But cosmic wildcards lurk. NASA's asteroid watch lists over 30,000 near-Earth objects, with Apophis brushing close in 2029, once feared to hit, now safe but a reminder. The DART mission 2022 proved we can nudge rocks. OSIRIS-REx sampled Bennu, a potential threat centuries out. Solar flares? The Carrington-level event odds are 1 in 100 years. A direct hit blacks out grids for months, costing trillions. ESA models show a superflare from our sun, rare but possible frying satellites. Longer term, in 1 billion years, solar brightening boils oceans. 5 billion, red giant phase engulfs us. But nearer, if the 27 million year cycle holds, subtle shifts in volcanism or impacts could brew. Supervolcanoes like Yellowstone erupt every 600,000 years. Last was 640,000 ago. A blast veils the sun in ash for years, starving crops. Seismic data shows magma rising, but no imminent boom. Where are we exactly? In the Holocene's tail. Anthropocene rising a warm blip in Milankovitch terms, but spiked by us. Hancock says we're post a 12,000-year catastrophe, rebuilding from survivors' knowledge. Evidence? Rising seas unearth submerged sites. Off India, Dwarka-like ruins. In the Mediterranean, prehistoric villages. Doggerland's ghosts resurface in trawler nets. If cycles repeat, the next younger Dryas analog comet swarm, or solar micronova, might strike unpredictably. A 2023 paper modeled comet fragmentation risks, estimating a 1% chance per century for global effects. Failed predictions teach caution. Nibiru dates flop, yet believers recalibrate. Biblical prophecies, Nostradamus quatrains get twisted to fit current woes. But real signs demand attention. Arctic methane burps accelerate warming. Antarctic ice shelves crack. Permafrost thaw releases ancient viruses, zombie pathogens from mammoths. A 2024 study revived 30,000-year-old viruses. Harmless now, but what if? Optimism balances dread. Humanity's ingenuity. We track threats, deflect asteroids, model climates. Renewable energy curbs emissions. Geoengineering ideas like solar shades float. But hubris echoes. Atlantis overreach invites fall. Elite bunkers suggest inequality in survival. Public prep lags. Synthesizing. We're likely in a transitional phase, interglacial peak juiced by humans. Magnetic vulnerability growing, biodiversity stressed. No single cycle screams now, but overlaps could cascade. A solar grand minimum cools amid warming. A reversal exposes us during high activity. An undetected asteroid slips through. Future scenarios branch. Best case, we mitigate, adapt, thrive into a multiplanetary species. Worst, tipping points unleash Venus-like hell or impact winter. Probable, messy decades of adaptation, migrations, tech saves. As signs swirl, storms rage, ice melts, stars watch our spot in the cycle, feels precarious yet pivotal. We've survived past beats. Will ingenuity outpace the rhythm? This reflection on now leads to a soothing close. Despite chaos, life rebounds. Let's drift into that renewal next, with a whisper of hope amid the mysteries. As the echoes of cosmic thunder fade and the last embers of ancient fires cool into silence, let the weight of all we have uncovered settle gently around you like a familiar blanket. We have walked the drowned streets of Atlantis, felt the gravitational whisper of Nibiru brushing the edge of nightmare, watched comets carve scars across the sky at younger Dryas, and listened to the slow, patient heartbeat of Milankovitch turning ice into water and water into ice again. We have counted the graves of 5 great dyings, felt the magnetic north slip from its throne, and stared into the blinding flash of gamma-ray spears and supernova afterglows. We have stood on the trembling lip of today, hurricanes howling, poles drifting, bunkers filling with the anxious elite, and ask the only question that truly matters: what now? Breathe. The story is not finished, and neither are you. Look back across the vast ledger of Earth's 4.5 billion year diary. Every page that records annihilation also scribbles, in quieter ink, the stubborn return of life. After the Ordovician oceans turned to poison, tiny survivors huddled in sunlit shallows and, within a few million years, spun coral cities brighter than any before. After the Great Dying left the world a fungal graveyard, a handful of beetle-sized reptiles blinked in the dawn and gave rise to every mammal that ever drew breath, including the one reading these words. After the asteroid punched Chicxulub and painted the sky black for a decade, a scruffy band of feathered dinosaurs learned to nurse their young with milk, and forests rose again on the bones of giants. This is the secret the rocks keep whispering. Extinction is never the final sentence. It is the comma that allows the next clause to begin. The planet does not mourn its losses, it composts them. Ash feeds soil, bones fertilize seas, and silence becomes the womb of song. Göbekli Tepe's buried pillars did not stay buried forever. Shovels found them, minds decoded them, and a new generation of dreamers now stands in their circles, asking the same sky for answers. The black mat of younger Dryas soot lies beneath wheat fields today, and children chase butterflies over ground that once knew only fire. Feel that rhythm in your own chest. Inhale the air that once choked Permian lungs. Exhale carbon that fueled Devonian ferns. Your blood carries iron, forged in the heart of a supernova that died before Earth was born. You are not separate from these cycles. You are their latest verse. When the magnetic field weakens and auroras dance to the equator, they paint the same curtains of light that guided the first humans out of Africa during the Lachant wander. When sea levels rise and swallow islands, they repeat the same choreography that stranded Doggerland's hunters and taught the survivors to build boats. History is not a line, it is a spiral, and every turn brings us higher or deeper depending on how gently we tread. Tonight, let the fear dissolve into wonder. The bunkers may fill, the prophecies may fail, the headlines may scream, but the deeper current is one of resilience. Coral larvae drift on currents that remember ancient floods and seed new reefs before the old ones finish bleaching. Seeds buried in permafrost for 30,000 years sprout when the ice retreats, as if time itself is only a long nap. Whales sing across oceans that once boiled, and their songs evolve with every generation, carrying memory in melody. Picture the earth from far above, a blue marble turning in the dark, scarred but luminous. Ice caps may retreat, but they have advanced and withdrawn 100 times before, sculpting fjords and plains like an artist who erases to begin again. Volcanoes may cloak the sun in ash, yet that same ash will settle into vineyards that produce wine sweeter than any before the eruption. Even the sun, swelling toward its red giant destiny billions of years hence, will first warm the outer moons enough for liquid oceans to pool beneath their ice, new cradles for life we cannot yet imagine. You, listener, are the living proof of this renewal. Every cell in your body has been replaced 1,000 times since you were born, yet the pattern that is you persists. In the same way, the pattern that is life persists through fire, frost, and cosmic hail. The mammoths fell, but their cousins, the elephants, remember the savannas in their bones. The trilobites vanished, but horseshoe crabs still patrol the tides like armored ghosts. Humanity may stumble through hubris, through greed, through forgetfulness, but the story has stumbled before and always found its feet. So let the mysteries cradle you now. Let the slow grind of tectonic plates become the lullaby of continents drifting to sleep. Let the flicker of distant supernovae be fireflies in the velvet dark. Let the memory of floods rock you like a boat on gentle waves, knowing that every deluge ends in dawn. The cycles are not chains. They are breaths. Inhale destruction, exhale creation. You are safe inside this breath tonight. Close your eyes. Feel the planet turning beneath you, steady as a heartbeat. Somewhere, a seed cracks open in volcanic soil. Somewhere, a child in a future classroom will trace the outline of a crater and ask, "What happened here?" And the teacher will smile and say, "Life happened again." That child might be your great-grandchild, or a stranger's, or a being we cannot name. The details do not matter. The pattern does. Thank you for walking these shadowed paths with me, for holding the weight of worlds in your imagination without letting it crush your dreams. This is Mystery History for Sleep, signing off with a promise: no matter how fierce the storm, morning always follows. The Earth has forgotten more catastrophes than we will ever know, and still it spins, still it greens, still it sings. Sleep deeply. Dream of forests rising from ash, of oceans teeming after silence, of stars exploding only to seed new suns. You are part of the rebound, the renaissance, the quiet miracle that happens every time the page turns. Good night. The cycle continues, and so do you.